Python's sets are like the Swiss Army knives of data handling. They offer simplicity, power, and functionality that can solve a myriad of problems, from eliminating duplicate entries to performing fast membership tests. But what are sets, really? They're a built-in data type in Python, quite similar to lists or dictionaries, but with a twist: unordered and unindexed. This nature makes sets distinctly unique, as the element order doesn't matter, and each element must be different, which inherently removes duplicates automatically. Now, diving into sets sounds intimidating to some, but fret not, my dear friends. This guide will equip you with the confidence to harness the power of sets in Python, ensuring you are not just handling data but manipulating it with finesse. We'll start with the syntax. It's surprisingly straightforward. To create a set, you encapsulate a comma-separated list of variables within curly braces. Elegant, isn't it? Here's the syntax in action. Python my_set is equal to 1, 2, 3, print. Now, this output might take some time to appear, but after a brief pause, you'll see 1, 2, 3. Notice that there's no order, as sets are inherently unordered. But that's not where their charm lies, is it? Moving on, it's time to touch upon some common set operations right within your Python skills wheelhouse. Union, intersection, difference, and symmetric difference might sound like complex terms, but all it means is how to combine or differ sets elements effortlessly. Let's roleplay with union. It's as simple as combining the elements of two sets without repeating common elements. Use the pipe operator or the union method. See it in action. Python set_a is equal to 1, 2, 3, set_b is equal to 3, 4, 5, union_set is equal to set_a vertical bar set_b print. This should print 1, 2, 3, 4, 5. Now, intersection. That's where only the common elements get celebrated. Here's how. Python intersection_set is equal to set_a dot intersection print. This should output 3 since 3 is the only common element. Let's play with some differences. Difference OR operator returns elements in the first set but not in the second. Python difference_set is equal to set_a, set_b print. This returns 1, 2. And finally, symmetric difference, or a method called symmetric_difference. It shows elements in either set, but not in both. Python sim_diff_set is equal to set_a dot symmetric_difference print 1, 2, 4, 5 is what we get here. There are more operations, trust me. But hold a thought. Sets in Python provide more than just operations. They come with inbuilt methods that simplify tasks. One of such methods is update, used to add multiple items. Let's see it. Python set_a dot update print outputs 1, 2, 3, 4, 5. You just added 4 and 5 to the set. Neat, indeed. We mustn't forget about the constructor method for sets either. You can create a set from other itables like lists or tuples. Here's an example. Python set_from_list is equal to set print. This will print 1, 2, 3. Now, my friends, I bet you are keen to handle sets, aren't you? To make your life easier, Python offers a convenient syntax for creating sets using the built-in set constructor function as well. Check this one. Python set_using_constructor is equal to set print. Remember, strings are iterable objects too. This returns HELO. Wow, look at that uniquity. When dealing with sets, we often encounter the lay function to get the number of elements in a set. Try it below. Python print should output 5. But there's more. Sets in Python play nice with other collection types. Imagine you have two dictionaries and you want all the keys from both. Look no further. You can use set operations to Python dict 1 is equal to A1, B2, C3, dict 2 is equal to B4, C5, D6, common underscore keys is equal to dict 1 dot keys and dict 2 dot keys print. This prints C are common keys. Now, remember, we can nest sets. And these nested sets can also undergo operations. Imagine a list of sets, and we wish to find unique elements across all. Here's an example. Python all underscore sets is equal to unique underscore elements is equal to set dot union. Print this should output 1, 2, 3, 4. Cool, isn't it? We could discuss this further with other set attributes and methods, but let's get to it, shall we? Before we wrap up, I invite you to dive into some real-world applications. Sets are particularly handy when working with large quantities of data. Imagine removing duplicate email addresses from a list. That's where sets become your best friends. Or finding common friends between user groups. What a simple yet relevant application it could be. I've also come across situations where I needed to perform an operation only once for certain elements in a list. For example, I might want to calculate a factorial for each natural number only once and store the result for future reference. Here a set could be beneficial, as its inherent property of eliminating duplicates could reduce the amount of computation required. These are just a few of the applications where sets in Python shine. Exerma, alright, you guys, I feel your energy, your excitement. So why not put today's lesson into practice? Take our initial lists as an example, and let's create a more efficient algorithm using sets. Here's how Python data is equal to unique underscore data is equal to set. Now, you have a set of unique elements only once. How about we filter our data and exclude all even numbers? Python unique underscore even underscore data is equal to x for x in unique underscore data if x% 2 is equal to 0, print that prints 8, 6 only even numbers now. How about if we find common friends between user group A and group B from our lists? Python user underscore group underscore A is equal to 2, 5, 6, 7, user underscore group underscore B is equal to 5, 6, 8, 9, common underscore friends is equal to user underscore group underscore A dot intersection print. The output will be 8, 5, 6 common friends between the two groups. You see, sets in Python are not just for show, they are powerful tools in our coding toolkit. I feel inspired and ready to conquer sets in Python, and I hope my journey has sparked that in you as well. So as you continue to learn and experiment with the power of Python, don't forget to explore deeper set operations and how they're implemented in Python's core. A handy resource is the official Python documentation on sets. Keep coding, stay curious, and remember, practice makes perfect. Now, as we come to the end of our delightful journey into the world of Python sets, I'd like to extend a warm invitation. Subscribe to our show, Technology Lab, and visit neeraj.xs.io on YouTube for more insightful content, including detailed tutorials on an assortment of Python topics designed to enhance your IT prowess. Until next time, keep mastering Python, and remember, with sets under your belt, the possibilities to create, analyze, and solve are endless. Now visit neeraj.qzz.io and subscribe to TechLab.